Here's a sample problem to work through involving kinematics and free fall. We're going to still use our strategy we've been using for solving kinematic problems, where we're trying to identify 3 of our kinematic variables. Once you know 3 variables and a 4th one that you're looking for, then you can look at your list of equations to pick one that uses those 4 variables. So press pause, take some time to read through this and try to solve it on your own, and then when you want to go through it with me, press play. So, just off the bat, kind of reading through this, I think there's 2 things that I think. It's pretty straightforward. They're asking how long it was in the air that whole time. That's like delta t is what they're asking me for. And they said it has an initial speed of 3 meters per second. Also, they say upward, so I know that's going to be positive 3 meters per second. So I'm going to say V initial is 3 meters per second. Now, I need to know the value of 2 other kinematic variables before I can choose my equation. Because remember, every equation has 4 variables in it. And if you know the value of 3 of them, you just have one unknown value in your equation. You'll be able to solve for it. So what else do we know about this? Well, we know that it was thrown from a height of 1 meter and it falls to the ground. So that's going to be useful. And we also know that it's in free fall, so we know what the acceleration will be. Let's deal with the change in the height first. So, because I want to really emphasize that you don't have to figure out, it's going to get thrown upwards and then it's going to fall down all the way down to the ground. You don't have to worry about the part where it goes up and comes back. All we care about in kinematics is delta y, and delta y is simply defined as y final minus y initial. Well, what's y final? It's 0. That's where the ground is. It lands on the ground. Y initial is the initial height. That's 1 meter. So our delta y, our displacement, our y displacement is just negative 1 meters. It doesn't matter that it goes all the way up and comes all the way back. That part there doesn't matter. Just like Usain Bolt running around a circular track, if he starts and ends at the same spot, his displacement was 0. Here we're not starting and ending at the same spot, but I don't care what happens during that little bit where he goes up and comes back to that initial height. I just care about he started at this height and ends up at 0. So these are the only 2 values that matter. I can say delta y is negative 1 meter. And then, as I said, something that's not mentioned here, but you have to know, it is in free fall, and the acceleration is negative 9.8 meters per second squared. So let me just tell you, this is the hardest part of this problem, right here. The hardest part of the problem is over. You're probably, when you study, if you're not paying attention to what I'm saying right now, you're going to study everything that comes after this. But that's not the hard part of the problem, and that's not the hard part of physics. The hard part of physics is figuring this out and remembering that this is true. That's the hard part. Once you get these 3 variables where you know the value and a 4th one that you know you're looking for, now it's easy. You don't have to really think that much anymore. You just look at your list of equations, you choose the equation that involves those 4 variables, and it's this one. And then you just plug in all the numbers. Here I've plugged in all the numbers, and you chug through the math. Now at this point here, you will have to do the quadratic formula. And you have to know how to do the quadratic formula for this class. So if you need to review it, go review it. Google it. Make sure you know how to do it, okay? Because I'm not going to go through the algebra that often. But just a reminder, real quick, you want to get 0 equals, and then the term that's being multiplied by the square term is your a. The term in front of the linear term is your b. And the term that has no variable next to it is your c. Here's the quadratic formula, and now I've just plugged in all my values. And with the quadratic formula, you will always get 2 answers. In this case, we're going to choose the positive one because it doesn't make sense for it to be in the air for negative 2.4 seconds. It does make sense that it's in the air for about 0.852 seconds. So you need to review this. You will need to know the quadratic formula.